Okay, this will be part 2 of the 3.1 video notes, and we're just going to kind of run through a few more examples of visual interpretation of a graph. So here we've got a three-way race, a 100-meter race. It ends in a three-way tie, so you can see at the 10-second mark, if you follow the time along the x-axis, the point A, B, and C runners are all in the same spot, so they've all ran a three-way tie. The idea for us here is to try to interpret how it is they ran the race differently based on the three different runners' graphs. So we got an A graph, A curve, a B line, I guess, and a C curve, and how do the runners run? Now, before we get into doing that, I think it's good to interpret what is happening as time passes. So we're covering distance over time, right? And what we want to do is look at some time intervals and see if we can kind of track the distances of A, B, and C runners, and then see if we can translate that to how it is that they ran the race. So let's look at the 3-second time interval and pop up some numbers here. So here are my A, B, and C runners' distances at 3 seconds in. Now, if you're just starting out by interpreting right away what's going on, the A runner has covered a good chunk of distance in a short period of time. The A runner is 60 meters into the race at 3 seconds. So the A runner is off to a really fast start ahead of everybody else. B runner is 30 meters in 3 seconds. So at a pretty steady pace. We'll have to see what happens in the 5-second interval to get a comparison. But is running at 10 seconds per meter. So we'll see if that's consistent. On the other hand, runner C is only covered 10 meters in the first 3 seconds, a really slow start. So that may be all that I know right now is that A has a fast start, C has a slow start. Now as we start to look at other time intervals, we'll start to see a pattern develop. So at 5 seconds, let's see what's happening. Well, at 5 seconds, A is still chugging along pretty good. At halfway through the race, runner A is basically 20 meters away from the end. So has covered a ton of distance in just half the race. B, 50 meters at 5 seconds, so another 10 meters per second. So what that means to me is that B is running a steady race, basically the same speed. And C has, covered some more ground, but still not moving very fast, halfway through the race and only covered a fifth of the distance. So this runner is definitely behind. Now, as we get to 7 seconds and we start to track what's going on, we'll see a little bit of a difference here. You notice that runner A now has covered a lot less ground, right? Only 10 meters in the next 2 seconds. So what that means to me is runner A is slowing down. B is still running steady, right? 70 meters in 7 seconds, so that's still 10 meters per second. So if you track B's pace, it's 10 meters per second at each interval of time. That's a steady run, same speed. Now, C has picked up the pace a little bit. In this case, in 2 more seconds, has covered 40 meters. So it was 10 meters in the first 3 seconds, picked up another 10 in the next 2, now picked up 40. So C is starting to speed up and kick it in gear. So describe the race. Well, if you guys ever visualize watching a track race and it's 3 or 5 runners or whatever, runner A is the person that I see as they get out of the blocks really quick, they get a lead, but then they slow down in the end, which means basically that the runners come up on that runner and they catch them or pass them. So that's your quick start, but a slow finish. B is just your steady pace. So B will get out of the blocks and maybe that runner A is ahead, but just get a speed going and run steady, which means B will start to slowly catch A from behind, but doesn't really speed up or slow down. So they're not sprinting at the beginning, they're not sprinting at the end, they just have a steady pace. Probably runner A sprinted right out of the blocks, hard as he or she could, and then just ran out of energy towards the end. Now runner C is kind of your opposite of A runner. Runner C is a slow starter, so they may actually just, get out of the blocks and slowly increase speed. And what happens to runner C at the end is that's that runner that you see when you watch a track race, is you see this person coming up from behind the pack and all of a sudden comes up from behind the pack, overtakes the pack, and maybe passes them to win, or in this case, ties, right? But runner C is that person who basically saves their energy and sprints for the last third of the race, uses all their energy and tries to overtake everybody else. So that would be a good interpretation of a pretty, classic track run, except a lot of times we don't get a 3-way tie, right? But a pretty typical scenario there. And the best way for you to understand all of this is to understand this. Think about what happens at corresponding time intervals and try to reason out what is going on with speeds and distances. Okay, the last problem is sort of tell your story. And so because you guys are student drivers, I designed this problem to be a possible scenario for you out doing driver's ed behind the wheel with an instructor. You're out traveling around town, and of course we're talking about things happening over time. what we're going to do is, consider everything to be time, right? So we're talking time. We'll fill in units in a second. What we're going to do here is consider this to be speed. So speed now two things we got to do. We got to label our axis. So there we go, right? Time and speed. Axis labels. We also got to label our units. Units are, what is the unit of time? Speed is kind of an easy one. That's miles per hour. Time, I suppose, depends. I think when you do a driver's ed behind the wheel session, you probably are not going more than an hour. I'm guessing maybe an hour and a half. But let's just say because maybe it's an hour at the most, maybe probably minutes does the job. So our speed as we kind of transpire over time. So to me, this is, first maybe 5 minutes, 10 minutes, another 10 minutes, maybe a couple minutes, maybe a 20-minute run here, so you kind of got the different time intervals. Trying to interpret the speeds is really what I want to think about is as I'm driving, what do these different colors actually mean? Now this is going to be my interpretation of my story. So at 0, 0, no time has passed and I haven't put my foot on the pedal yet, right? So the instructor pulls in my driveway, picks me up, I get in the car, time to start driving. So I drive, and it's kind of a shorter, maybe 5 minutes, not that much, or could be 10 minutes, who knows, but I drive for a little while, I'm increase my speed, but you notice I'm not going really fast in comparison to this speed. So I think here I'm probably in town, on a city street. So I take off, speed up a little bit, and then maybe I just come to a stop sign. I come to a stop sign and I take a quick look, in every direction, then I just start going again. And again, I must still be in town because I'm not traveling really fast, but I'm also coming up on something. Now you could say stop sign, but because there's a constant here, it means for this little interval of time, I'm sitting there not moving, no speed. So to me, this red kind of reminds me of like a stoplight. So, I go, speed up, city street, slow down, hit a stoplight. Now because of this part of the graph, and I'm really got this major increase and then a level off, I might have to rethink what's going on here. So I might go back and say, well, how am I going to get this major increase of speed if I'm still in town? So I think maybe green is actually me getting onto an on-ramp to the highway. And it's metered. And if you guys have been trying to get on, like say 169 off a Pioneer Trail, you notice you got the little mini stoplights, 2 sets on each side of the ramp to meter the traffic so it can stagger the cars. So maybe I'm actually getting on the on-ramp, and then I slow down at the meter part, stop at those sets of lights, and I wait for a couple seconds till my light goes. And then as soon as it goes, here's the on-ramp, the rest of the on-ramp. So now I'm going to hit the gas, right? I got to get up to speed because I'm about to get on the freeway. And maybe in here, I'm finally up to actual speed limit, but then all of a sudden I slow down and then I level off again. So now I might go backtrack a little bit and go, well, okay, in here, maybe here's what I think is happening. I speed up and maybe there's a car coming down the highway and I'm going to merge and I got to get ahead of that car. So I hit the gas and I speed up. I'm actually maybe above the speed limit for a little bit. I merge, I'm on the highway, and then all of a sudden I realize, wait a minute, I'm traveling above the speed limit, so I slow down. And then I set my cruise or whatever and I'm at the speed limit now. So there is one interpretation of what's going on. Your story as a driver yourself, been out there, you might interpret that whole graph differently, but I think the in-town and freeway stuff is probably the same. Domain and range. So when we do domain and range, last questions here, is we talk about what are X and Y values in this graph. Well, domain is definitely what we consider to be X, and we haven't really done a whole lot talking about domain and range, but these are X values, range are Y values. And what we do is kind of think about it as what's kind of the range of from where to where, right? So our time, from what to what? Well, our time basically is 0 to, if we're saying an hour trip, we're between 0 and 60. Range-wise, speed, 0 till you actually hit the gas and go somewhere. Range, if it's freeway speed, maybe we're saying 70 is kind of our upper limit. Then what we do is we actually apply some inequalities in here. And we say X is greater than or equal to 0, but it's less than or equal to 60, which means that puts us between 0 and 60. And Y is greater than or equal to 0, so time's going to pass, of course, once we start driving. Speed is going to increase once we start driving, but if we're going to follow the speed limit, we're not going to get above 70. So when Y is greater than 0 going this way, it's less than 70. So when you do domain and range, you're talking about what's acceptable for the problem, what makes sense for the problem. Okay, that's the end of our 2-part video for Notes 3.2. That should do the job. Hopefully everybody gets a chance to watch it before tomorrow.